You're welcome to New Focused Approach to Mathematics Basic 8. This is the revised edition, and in this video we're looking at real-life application of sets, that is two set problems. Now let's take this scenario. I'm going to have two circles, or let me first say that, okay, we have a universal set which we call the rectangle, and the universal set means all the elements here can be found in this big set. Now let's have a subset called multiples of 3 and another subset called even numbers. Now what we want to do is we want to put in all these numbers into the various sets, into the various regions created here. Now the question is, where will I put 2? Is 2 a multiple of 3? No. Is it an even number? Yes, so I can put 2 here. Now, can I put 2 here too as well? The moment I put 2 here, then I've made 2 part of the multiples of 3, which is not true. And so I can't let 2 come in between the blue and then the brown circles. Okay, so I can take away the 2 from here. Now the next number is 3. Where should I put 3? 3 is a multiple of 3, and it can't be even number, so I can put 3 here. What about 4? 4 is an even number, right? So, and it's not a multiple, so I can put it here. 5 is not an even number. It is not a multiple of 3 either. So it means it will be outside the 2 circles, but inside the universal set. Then 6 is a multiple of 3, at the same time even number, so I can put 6 in between. That means here it is part of multiple of 3, at the same time it is part of even numbers. But with the 2 and 4, they are only, you see the word only, even numbers. They are not multiples of 3. What about 7? 7 too is neither multiple of 3 nor even number, so we put it outside the circle. What of 8? 8 is only even number, so it comes here. What about 9? 9 is only multiple of 3, is not even number, so it will go here. 10 is even number, so it comes here. 12 is a multiple of 3, at the same time it is an even number, so it will go this way. This illustration gives us the regions that we are going to work with as far as our two set problem is concerned. So we've seen region here, region here, region here, and region there, or there. So you can see that these 4 different regions speaks to the diagram. It tells you what belongs to what. So we have 4 regions here, and all these regions, for example, you see region 1 tells us that we are dealing with A only, which is A intersection B complement. That means it is in A but not in B. And then all elements that falls in region 2 are in both A and B. We call it A intersection B. Then region 3 tells us B only, which means the element is in only B. It is not in A, so we call it A complement intersection B, A complement intersection B. Then the final region, which is the region 4, which is outside the 2 circles, but inside the rectangle, is neither A nor B, or element outside A and B. We call it A complement intersection B complement, meaning not in A and not in B. Right, so these are the regions we are going to work with. Let's take one example and see how it works with two set problems. Okay, in a certain school, in a certain SHS class, 55 students are studying history or geography or both. That means the whole class. Okay, if 30 of them are studying history and 40 studying geography, S of them are studying both subjects. Represent this information on a Venn diagram. Find the value of X and how many of the students study only one subject. Okay, so now in doing this, what we have to do is to let maybe you be the student, okay, student, and that gave us number of U to be equal to 55. Okay, so you define all the parameters. You can say let H also represents student, or let's say history students, those who took history entirely, and that we can say number of H also is equals to 30. Do the same thing for, so number of geography is 40, number of those who study both history and geography is X. Now after doing this, we draw your Venn diagram and then you represent all the information there. So here we can put our X here. So now we have all those who study history, they are with this circle. So that means X plus those who are only here together should give us 30. So for us to get those who are only in this particular region, we can do simple subtraction by saying 30 minus X. And those over here can also be 40 minus X, so that we can get only those in that region and only those in the geography region as well. Now, because the question wants us to find the value of X, we know that if we add all the elements in the region together should give us the 55. We can say 30 minus X plus 40 minus X all should give us 55. That is what we have learned, that's the universal set. All the elements in the set, but there isn't anybody who is outside the two sets, so there's no complement here, right? Now when we do simple cancellation, so simple algebraic here, we can say negative S plus S will give us 0, 30 plus 40 will give us 70, minus the S equals 55. If you group like terms, we can have 70 minus 55 is equals to X. And so we can say our S will therefore be equal to, so S will be equal to 15. Now that we know S to be 15, if the question is asking us how many of the students study only one subject, all we can do is to get those who are here alone. Okay, when I take away 15 from this, I have 15 here, and then here too is 15. Then I have 25 here as well. So if you say how many of the students study only one subject, those who did only one subject are 15 and 25. When you put them together, that is going to give us 40. So 40 students study only one subject and 15 students study two subjects. That is that. I'm sure with this illustration, it has given you a fair idea as to how to handle two set problems. There are a lot of questions in there. With your knowledge from the onset, how I was able to break the various components and then the regions, you should be able to solve more questions on your own. Thanks so much for watching.